In this video, we're going to see how to compute the determinant of a 3x3 matrix. It's certainly not as easy as computing the determinant of a 2x2 matrix, but it's still not too bad. So here's how we do it. If we're starting with a 3x3 matrix like this, what I'm going to do to make this computation, I'm going to copy down those same first two columns again next to the matrix. And the way it's going to work now is I'm going to take products across the diagonals like this and add them up. So I'll have A times E times I plus B times F times G plus C times D times H. Then I'm going to take products along backwards diagonals and subtract those. So I'll have minus C times E times G minus A times F times H minus B times D times I. Or you might like to write this as A E I plus B F G plus C D H minus, pulling the minus out of each of these terms, C E G plus A F H plus B D I. So let's compute one. So again, I'm just going to copy down, and I'm going to take products along those forward diagonals and backwards diagonals and take the difference. And when I do that, I'm going to get 2 times 0 times 1, that's 0, plus 1 times 1 times 1, that's 1, plus minus 3 times 1 times 2, that's negative 6, minus, going along the backwards diagonals, I'll have a 0, 2 times 1 times 2 is 4, 1 times 1 times 1 is 1. And if I put this all together now, I'm going to get negative 5 minus 5, so that's negative 10. So the determinant of A is equal to minus 10. Since we're here, let's do one more example. And then in the next video, we'll see a few easy applications. So to compute this, I'm going to, again, just copy down those first two columns. Minus 2 times minus 5 is 20. 1 times 1 times 2 is 2. 4 times 0 times negative 3 is 0. And if I add these up, it looks like I have 22 minus 22, so the determinant of this matrix is 0. Now, just as in the case with the 2x2 matrix that we saw before, having a 0 determinant tells us a couple of things. It tells us that that linear system AX equals B either has no solution or it has infinitely many solutions. It also tells us that the column vectors of the matrix are linearly dependent and that the matrix is not invertible. And we're going to see more of this as we go through the next videos and see a few easy applications. So let's do that.